Hello everyone and welcome back. Today we are going to talk about some AI modeling fundamentals. Right now I am in Schwarzwald. It's such a nice weather, so I am recording at least the beginning of this video in outside. So let's talk about the basics. We will talk about entity relationship modeling for conceptual database design. We will cover entities for real-world objects or concepts and attributes, properties describing entities, as well as relationships between entities. Key subtopics include identifying primary keys in the entities, understanding relationships like cardinalities, one-to-one, one-to-many, many-to-many. We will have some diagrams. We will draw some diagrams, and the participation of them, mandatory versus optional, like resolving many-to-many relationships by introducing associative entities like junction tables, and recognizing special relationship types like recursive relationships. By the end, we should be able to translate a real-world scenario into an ER diagram with proper notation. An entity represents distinct object or concept like customer or product, whereas an attribute is a detail about an entity, customer name or product price. It's important not to confuse the two. For example, customer is an entity, while customer address might be an attribute of the customer entity. When we look at the introduction of AI model in Geeks for Geeks, we can see very well explained and informative basics of the entity relationship model. We can see differences between entity, attribute, and relationships, which we will talk in the future. Why we use them, the symbols, what's an entity set, what is an attribute, and continue. You can check this website. I will share the link somewhere, which is very informative. And we will also talk about these in detail. Entity relationship model, a high-level data model using entities, attributes, and relationships. We introduced the notion of an ER diagram, which graphically shows how entities relate. The ERM is the blueprint of the database at the conceptual level. Let's talk about relationships and cardinality. A relationship connects two entities like customer, places, order. We explain cardinality notation like one-to-one, one-to-many, many-to-many. For example, one customer can place many orders, which means one-to-many, but an order is placed by exactly one customer. We also discuss mandatory versus optional participation. Does every order must have a customer? Yes. Does every customer have to place an order? Maybe not. Many-to-many relationships cannot be directly implemented in the relational model, so they are resolved by introducing an associative entity, also called a junction table. In this example, we have a student which can enroll in many courses, and each course has many students. We will create an enrollment entity to break this into two one-to-many relationships. In this example, we have students. One student can enroll in multiple courses, and a course can have many students. We have recursive relationships, where an entity is related to itself, like an employee supervises another employee. For example, one employee can supervise many. One employee as a supervisee supervises many, but each employee has at most one direct supervisor, forming a hierarchy. Although detailed implementation of keys is logical design, we mention identifying primary keys for each entity or unique identifier, and note that relationships often imply foreign keys later on. For instance, if department and employee are entities with one-to-many relationship, the UI model indicates each employee is associated with one department, hinting that a department ID will appear in the employee table as a foreign key. We will talk about this more in detail, and I will show some diagrams and examples. Before we dive into details to example, let's quickly understand the cardinality notation we will use in ER diagrams. First, we have a line with another line, which means 1. We have a line with close fit at the end, which means many. We have a line, which means one and only one. We have a line with a line and a circle, which means zero or none. We have another line with close fit plus a line, which means one or many. We have another line with a circle and close fit in the meaning of zero or many. Let's apply what we learned in real world scenario. Imagine we are building a database for a retail store's inventory system. And for now, let's focus on this part between salesperson, customer, and order. So basically, a salesperson may manage many other salespeople. A salesperson is managed by only one salespeople. A salesperson can be an agent for many customers. A customer is managed by one salespeople. A customer can place many orders. An order can be placed by one customer. We mentioned the recursive relationship in previous slides, but here I just want to clarify it. Let's say we have a salesperson and it is supervising another salesperson, which is just recursive means. One salesperson or one employee can have zero or many supervised employees, and each employee has one supervisor. Another example, we have primary keys. So each entity should have a primary key, which means a unique identifier. For instance, here we have supplier and supplier ID, which is its primary key. Same for part and part ID, which identifies each part. And when we have a supplier part table that comes from part and the suppliers, we can see supplier ID and part ID comes as foreign keys. In this case, a supplier supplies many parts, but a part can be supplied by many suppliers. In this case, one-to-many relationship between supplier and part, we accept the foreign key, supplier ID, and part ID to appear in supplier part table during logical design. We don't design tables yet, but this link between the conceptual and logical level is important to understand early. I have another example diagram here, which basically a library ERD. For now, we can focus on the loan and the book part. As you can see, a book is borrowed in loan in many and single relationships, which means a book can be loaned many times, but you can loan a book once in a time. And book ID is here our primary key, which connects to the foreign key as a loan, which comes from book.book ID. Now let's see how a part of our library ERD becomes real tables in SQL. This is not the exact same copy, but just to give you an idea, I want to talk about the loan relationship between book and user, which we have loan ID, primary key for the loan. We have book ID, which is foreign key for loan that comes from book's book ID. And we have user ID, that the user who borrowed the book, that's also a foreign key, which comes from user and user ID. And if you can see here in our create table loan SQL statement, we have loan ID as primary key, as I mentioned here. We have book ID. We have user ID. We have loan date. We have return date. And as a foreign key, we have book ID, references the book ID, and user ID references the user's user ID. This SQL structure enforces the relationship defined in ER model. And this mapping is what makes ER modeling useful. Without it, we wouldn't know what tables to create or how to connect them. Here's a question that has appeared on multiple different exams, and it basically is design an ER model for a retail store inventory system. First, we need to identify all major entities, like what we want to have, product, supplier, or purchase order. We should determine relationships like supplier supplies product, employee creates purchase order. We have to watch out for many-to-many connections, resolve them using junction entities. The result should be clear AI diagram with all relationships showing cardinality. I will give the link in the description, but you can try to create something like this, or just look at it, stop looking, try to write yourself. I think it would be useful to exercise and understand what we need to know about ER diagrams and relationship diagrams. Or another example, we can have recursive relationships. It can just ask what is a recursive relationship, give an example. As we showed in the previous slides and also here, when you go to the salesperson, this is a recursive relationship, or employee, whatever you like to call that. To define the term, a recursive relationship is a relationship where an entity is related to itself. We can have employees provides other employees example, and we can have one-to-many relationship, and it can be recursive. In our ER diagram, this is drawn with a loop, as I showed here. This is a loop. And if the if you see a question that says draw an ER diagram for this, don't forget to use correct notation for the loop, or it will not make you any points. And in the idea, it is kind of simple. I would suggest, again, check the examples and try to do it yourself. To summarize, to wrap up everything, ER modeling helps us design the database conceptually. We define entities, their attributes, and how they relate. Make sure you understand cardinality. We can recognize and resolve many-to-many relationships known, and we can know how to map ERDs to tables in the example I showed. If you see a ER modeling example, it often appears, and you should be able to know what you need to deal with. And yes, basically these are the points we talked. I hope this was helpful. And in the next video, we will move from conceptual level to relational schema design and normalization, and how we can ensure our tables avoid redundancy and structured efficiently. So thank you for watching, and see you in the next one.